Linear equations in two variables. We have started linear equations in two variables. So let's recall. Can you identify the equation given below? 3x plus 4y equal to 24. Here we can see we have two variables x and y. The power of x and y, both the variables is 1. That means it's a linear equation. And since there are two variables, we say that this is a linear equation with two variables. So in the last class, we have seen how to solve linear equations simultaneously. That is, when we have two linear equations and we are solving them simultaneously to get the values of x and y, the solution of the equation. So can you tell me that can we use the linear equation to solve sums related to daily life? Can we use the linear equations and find solutions to sum related to daily life? Let's check with one example. Here we have an example of rectangle. We don't know the value of the length and the breadth of a rectangle, but we have some figures and we need to find the length and breadth of the rectangle. So in this case, we have two unknown things, that is the length of the rectangle and the breadth of the rectangle, right? So when you have two unknown things, we can take it as a variables x and y, right? So in the box, you can see it's written like I am a rectangle and my length is x and this is y. So we're going to consider these two unknown things as x and y. Now we need to use all the data that's given over here and try to frame linear equations and then solving it simultaneously once we get the value of x and y. That will be the length and breadth of the rectangle. Okay, so let's read. Sum of my length and breadth is 36. So when you read it as sum of my length and breadth is 36, what do you mean by sum? Yes, sum means addition. So adding your length and breadth is 36. Since we don't know what is the length and breadth, we have considered it as x and y. So x plus y equals 36. Perfect. So here you can see that we have two variables x and y, two unknowns, and the degree of x and y is 1. That is, this is a linear equation in two variable. Now to get the solution of this linear equation, we need one more equation so that we can solve it simultaneously. So let's use the other data that is given for us. Difference between my length and breadth is 6 units. So when the word difference comes, what do we do? Subtract. Perfect. So x minus y equals 6. So here the difference of length and breadth is 6. So here you can see that you have a linear equation, two linear equation. First one is x plus y equals 36. Second, x minus y equals 36. X minus y equals 6, right? So you can solve this simultaneously, and after solving it simultaneously, you're going to get the value of x and y. That will be your unknown length and breadth. So here you have seen that when we have a particular condition situation given where we need to find an unknown thing, we can frame a linear equation by using the given condition. Once we get two linear equations, we can solve them simultaneously and get the value of x and y, right? Here, like we had length and breadth were unknown. So we use the given data, we frame two linear equations. We are going to solve it linear simultaneously and we'll get the value of x and y. So this is the application of linear equation to real world. Yes, so whichever sums we get when we have a word problem, first thing we need to identify what we need to find. There can be two things that we need to find. So that two particular things will be your variables, will be denoted by your variables because they are unknown. You don't know the value. Like in this condition, it was your length and breadth. It can be someone's age. It can be the amount that you need to find depending on the sum we are going to solve. that variables, that unknown things, we are going to denote by the variables x and y, any other variable. It can be any other variable. Then, using the given conditions, we'll be framing two linear equations. After framing the linear equations, we are going to solve them simultaneously, and we will be getting the value of x and y. That will be an unknown. So now let's see how to solve the word problems. We'll be solving 2 to 3 word problems together.
Equation. The sum of father's age and twice the age of the son is 70. If we double the age of father and add it to the age of son, the age is 95. Find their present age. Now, once we read the question, we come to know that the question is dealing with father's age and son's age. That is two things. And our linear equations also has two variables, say x and y. So we can consider x as father's present age and y as son's present age. Now we'll try to frame the equations. So we'll read the question once again. The sum of father's age and twice the age of the son is 70. So here the word sum means adding. We are adding son's age and father's age, x plus y. But next condition is the age of son is twice. So the equation will be x plus 2y is equal to 70. Sum means addition. So we are adding the age of father and his son, and age of the son is twice. So 2y. So x plus 2y is equal to 70 will be our first linear equation. Now to frame the second equation, we'll come to the next part of the question. It says if we double the age of the father and add it to the age of the son, the sum is 95. Again, here we are going to add two things, age of the father and age of the son. But the condition is double the age of the father, that is 2x. So equation will be 2x plus y is equal to 95. So we got two linear equations, x plus 2y is equal to 70 and 2x plus y is equal to 95. Now we'll solve this equation simultaneously to get the values of x and y. X is equal to 40, y is equal to 15. Therefore, the present age of father is 40 years and the son is 15 years. Two types of boxes, A and B, are to be placed in a truck having capacity of 10 tons. When 150 boxes of type A and 100 boxes of type B are loaded in a truck, it weighs 10 tons. But when 260 boxes of type A are loaded in a truck, it can still accommodate 40 boxes of type B, so that it is fully loaded. Find the weights of each types of boxes. This question is dealing with two types of boxes, A and B, which are to be loaded in a truck. And they have given us that we need to find the weight of box A and B. So we need to find two things, weight of box A and weight of box B. A linear equation in two variables, we can consider x and y. Therefore, box A, that is weight of box A, will consider it as x, and weight of box B will consider it as y. Now let's try to frame the equation. The box are to be loaded in a truck having capacity 10 tons. 1 ton is equal to 1000 kg. Using this, 10 tons will be 1000 into 10, that is 10,000 kg. Therefore, the capacity of the truck in kgs will be 10,000 kgs. 150 boxes of type A and 100 boxes of type B are loaded in a truck. It weighs to 10 ton. The weight of type A box is x kg. Therefore, the weight of 150 such boxes will be 150x. Weight of box B is y kg. Therefore, weight of such 100 boxes will be 100y. Now, the capacity of the truck is 10 tons, and this 150 boxes of type A and 100 boxes of type B are loaded in the truck. That is, both the boxes are loaded in the truck. Therefore, we can add this weight. That is 150x plus 100y is equal to 10 tons. Why we are adding this? Because truck has the capacity of 10 tons and 150 boxes of type A and 100 boxes of the B are loaded in the truck. So we'll add the weights. Weight of 150 box of A plus weight of 100 boxes of the B will be equal to the capacity of the truck. So the equation will be 150x plus 100y is equal to 10 tons. This equation we can simplify by dividing by 10. Coming to the next part. But when 260 box of type A are loaded in the truck, it can still accommodate 40 boxes of type B, so that it is fully loaded. Now here, first, the truck is loaded with 260 type boxes of type A. So the weight of these boxes will be 260x. Now the remaining capacity is that it can still load 40 boxes of type B. So the weight of this 40 boxes will be 40y. And total, adding this weight of this 260 box and 40 box of B will be the capacity of the truck. So again, equation will be 260x plus 40y is equal to 10 tons. And this also equation we can simplify by dividing by 10. So the equation will be 26x plus 4y is equal to 1000. Then solving these two equations simultaneously, we'll get the values of x and y. X is equal to 30, y is equal to 55. Therefore, the weight of box A is 30 kgs and weight of the box B is 55 kg.